Okay, so good afternoon, guys. We are going to start a class. So those who are not able to join, so please join. Okay, Gala, good afternoon. Aditya, good afternoon, and everyone, please ping inside the chat. Tushar, Rishabh, good afternoon. Aditya, good afternoon. Sri, okay, good afternoon, everyone. Raghavendra, Murendra, Dinesh, Pradeep, Tyaga, good afternoon, everyone. Okay, shall we start, guys? So just ping me in the chat, then we can start. Okay, so let's start. So yeah, anyone who can just recap quickly that what we have discussed in our yesterday's class, because yesterday we were talking about statistics and we have discussed about a couple of terms while talking about the statistical concept. So if any one of you can just revise the main topics, I think that will be better. So Arvindan is saying, what is statistics, central tendency? Yeah, we have discussed about central tendency. Then anyone? I think we talked about mean, median, mode, ranges, standard deviation, variances. So these are the things that we have discussed in our yesterday's class. So again, this class is going to be a continuation of the same class and whatever we have discussed. So we are going to extend the same lecture. So let me share my screen. I believe my screen is visible to all of you, and let's get started. Let me close all that unnecessary tab that I have. Just a minute, guys. I have to close some of the processes which is running inside my system because there are so many things which is actually running, and it is slowing down my system a little bit. Okay, so let's get started. So stats part 2. Now, in my studies class, so I was talking about basically mean, median, mode, variances, standard deviation, and a range. Plus, we talked about what is statistics and what is a population, what is a sample, and how we'll get to know what is a population, what is a sample, and all those things. Fine. Now, in today's class, so we are going to talk about a skewness into a data set. So whenever you will be having a data set, so you have to find out a skewness inside a data set, and based on that particular finding, so what is a skewness into a data set, you will have to do a treatment of a data set. So first of all, we are supposed to understand that how, based on the concept that we have already discussed in our today's class, how we will be able to find out a skewness into a data set, what in all different kind of a skewness which exist inside a data set, and then how we can try to find out in a programmatical way as well. So in a theoretical way plus in a programmatical way in my today's class. So we are going to discuss about these concepts. So let's get started, guys. So first of all, what I will do is, so I'll try to take one small data set, and yes, let me write down the topic. So skewness into data. This is something that we are going to discuss in a first place. So here, let's try to take a data. So let's suppose I have some random data, 1, then 2, and then 100, and keep your calculator ready, guys. So we have 200, we have 3, we have 4, we have, let's suppose, 8, and we have basically 10, we have 5, we have 2, we have 3, and we have 6. So this is the data set. This is just a sample data set which I have taken. Now, so in a very first place, I have to find out that whether my data set is right skewed, or whether my data set is right skewed or left skewed, or my data set is a symmetric data set. How I will be able to identify that part? Because if I talk about the skewness, so there are 3 kind of skewness you will be able to find out. So the very first part is basically 0 skewness. And this is also called as symmetric data, or like a symmetric, like a data set. Symmetric data. There is a second kind of skewness you will be able to find out, which is called as right skewness, or it's also called as positive skewness. And there is a third kind of a skewness you will be able to find out, which is called as left skewness or negative skewness. Now, so here is our data set, and we have to figure it out that whether this data set is a symmetric data set, or this data set is a rightly skewed data set, or a left skewed data set, or symmetric, positive, or a negative skewness exists inside this particular data set. Now to do that, right? To do that, so theory says that if mean is equal to median is equal to mode, right? So mode, in that case, that data set will be having a 0 skewness. So you won't be having any kind of a skewness at all. So 0 skewness you will be able to get. And theory says that if mean average is greater than median and it's greater than mode, then we will be having positive or right hand side skewness. And if mean is lesser than median is lesser than mode, then it will be negative. Fine. So this is just a theory. This is just an analogy as of now, and we are completely like not aware about any of these things so far, so forth. We are just aware about how to find out mean, how to find out median, and how to find out mode. This is the only thing that we are aware about so far, so forth. And here is a data set which is given to me. Now we have to find out, first of all, mean, median, and mode. And based on this analogy, we'll try to figure it out that whether my data set is skewed or whether my data set is not skewed. So fine, guys, calculate it quickly. So what is a mean of this data set which I have given to you? What is a median of this data set which I have given to you? And what is a mode of this data set which I have given to you? Yeah. So people are directly saying in a chat that it's a right skewed. Amarendra is saying, is there any WhatsApp group for the data science classes? We have a WhatsApp channel for that. And okay, so Rishabh is saying mean is equal to 28.67, median is equal to 4.5, mode is equal to 2.3. Okay, Raj is saying the same thing, 28.6. Then mode is 2, median is 4.5. Here is saying mean is 27.83. So I think it's 28.67. So just right before your class, I have given the same data set, and we have over there, we have done the manual calculation for everything, right? So here we have mean is equals to 28.66 around, or 67, and median is equals to 4.5, and mode is obviously we have 2 and 3, as 2 is repeating I think twice and 3 is repeating twice in this one. So we have 2 and 3 as a mode. Now just with this analogy, right? So just with this analogy, so what we are able to figure it out. So in which criteria, in which condition my data set is falling. So let's suppose this is the condition number 1, this is the condition number 2, and this is the condition number 3. So can I say that my data set as per this mean, median, and mode that we are able to find out, it is falling under condition number 2? Yes, guys? Yeah? Yes, everyone? Fine. So I can say that Abhishek is saying stream is stopped. I don't think so, Abhishek. We are able to see the stream. So here I can say that yes, as per this 3 given conditions, so my data set is falling under condition number 2. So where mean is greater than median and greater than mode. So obviously I have a positive skewness inside my data set. I have just a positive skewness inside a data set. So fine, we are able to understand that this data set is positively skewed, means on a right hand side, basically positive skewness means a right hand side skewness. So on a right hand side there are some outlier, means on a higher side or positive higher side. So I have some data set which is basically behaving as an outlier. And if you will look into your data set, right, even if you will look into your data set, so yes, we have 100 and we have 200. Most of our data set is ranging between 1 to 8 or 10, I can say. So most of the data set is ranging between 1 to 8. So where we have a higher density of the data set. And these two data set is very, very far from the actual data set that we have. The actual ranges of the data set or the normal ranges of the data set that we have. And based on that, I can claim that okay, so this data set is basically a right skewed data set. Okay, that's completely fine. Now let's try to draw a graph. So let me write down this data once again over here. So my data set is basically 1, 200, 200. So 1, 2, then 100, then 200, 3, 4, 8, 10, 5, 3, 4, 8, 10, 5, 2, 3, 6. Okay. So 2, 3, 6. So we'll try to plot a graph, guys, over here manually. We'll try to plot a graph, and then we'll try to see that whether we are able to establish the same kind of analogy or not. So I'm trying to claim that right skewness. So my data set is basically rightly skewed. And what is the meaning of right skewness? You will be able to understand after that. As of now, we are able to understand that it's a positive side skewness. So the word that I have written over here, positive skewness. So as of now, we are able to understand that, okay, my data set is skewed on a positive side, means on a higher side of the data, positive higher side of the data. So I have some sort of outliers which is available inside my data set. Okay, fine. That's great. Now here, just do one thing. So we are supposed to prepare one small table in this particular place. So here you are going to keep your data, and then you are going to keep a frequency of the data in this particular table. So frequency of the data you are going to keep in this particular table. So we have a data over here. So data wise, what we have? So we have 1 distinct data wise. So we have 2, we have 3, we have 4, we have 5 inside the data, we have 6 inside the data, we have 8 inside the data, we have 100 inside, 10 we have inside the data. So we have basically 10 inside my data set. So I have 10 over here, then I have 100, and then I have 200 inside my data set. Okay, that's fine. Now, what is the frequency of 1, guys? So how many times 1 is occurring inside my data set? So 1 time. How many times 2 is occurring inside my data set? 1 times. How many times 2 is 2 times basically. How many times 3 is occurring? So 2 times. How many times 4 is occurring inside my data set? 1 time. 5, again 1 time. 6, again 1 time. 8, 1 time. 10, 1 time. 100, 1 time. And 200, 1 time. Okay. So this is the data and this is the frequency that I have written. Now just do one thing. Let's try to plot a graph. So we have a x-axis and then we have a y-axis. So here we are going to plot a 2D graph. So where we have a x-axis and we have a y-axis. On x-axis, we are going to keep our data set. We are going to keep our data set, and on y-axis, so we are going to keep this frequency part. So on y-axis, we'll be having a frequency, and on x-axis, we'll be having our data set. So fine, here is a 0 coordinate, and then we have like a 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, and then somewhere far away from this, so we'll be having 100, and then we'll be having somewhere 200. Okay, we'll be having 200. So fine, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then far away 100 and 200 will be having. So on a x-axis, like I said, we are going to give a data. On y-axis, we are going to give basically a frequency of the data. So 1 is occurring, right? So 1 is occurring. How many times? So 1 is occurring basically 1 time. So let's try to keep it here. So 1 is, let's suppose here, 2 is here, and 3 is here. So 1 is occurring how many times? 1 time. So I'm going to plot a dot. So here data is 1 on 1. So this is 1 1 coordinate, 1 1 coordinate, right? So this is 1 1 coordinate. Now 2 is occurring twice. So 2 is occurring basically twice. So we are going to get a coordinate somewhere over here. 3 is occurring twice. So we are going to get a coordinate somewhere over here. Now 4 is occurring 1 time. So coordinate somewhere here. Then 5 is occurring 1 times, coordinate somewhere here. 6 is occurring 1 time, coordinate somewhere here. 7 is occurring 1 times, coordinate somewhere here. 8 is occurring 1 times, coordinate somewhere here. 9 is 9. There is no 9, right? So we can try to delete this one. Now 8 is occurring here, and then we have a 10 over here. And then we have 100 is occurring 1 times, and then 200 is occurring 1 times, far away from the original data set. Now just try to draw a box. This is basically called as histogram. So we are going to draw a histogram over here. But yeah, so as of now, we are not aware about histograms. So just try to draw a boxes as I am drawing as of now. So here, then here, then here. And then we have like 10 over here, or precisely it is going to be like this. This you can try to remove it. Okay. So this is basically histogram. And then we have 100. So maybe you can draw it in this way. We have 200 for now. You can try to draw it in this way. Now, if you are going to combine the edges, so just try to combine all the edges over here. So if I'm going to combine all the edges, and I'm going to make some sort of a slope in this particular place. So can I say that most of my data distribution, which I'm talking about as of now, so most of my data distribution actually exists in this particular space. Most of my data distribution exists in this particular place, and there are very few data. There are only 2 data, or I can say there are very few data which is existing very far away, and technically it is trying to form a kind of a tail for me, right? It is trying to form a kind of a tail for me in this particular space. Simple. So it is trying to form a tail for me. So can I say that this data set is skewed, right? Means there are very few data, means there is an outlier on right hand side. So on right hand side, you have a very few data. So basically it is forming a tail of the data. Majority of the data exists in this particular space for me, not over here, not on this particular side. So again, we are able to prove based on the frequency distribution versus a data plot that yes, my data set is rightly skewed. My data set is rightly skewed, or on a positive side, right? On a positive side, my data set is technically skewed. And because of that, I'm able to see a tail in this particular space. Can I make this statement, guys? Yeah, 7 is not in a data set. Yeah, that's true. You can remove this one. Again, it is not going to impact anything. So you can remove this part as well. 7 and 9 is not a part of data set. Fine. Yeah. So even in this way, I'm able to prove that, okay, so data set is rightly skewed. So now we are able to understand what is the meaning of right skewness or a positive skewness. Both are same, right? So we are able to prove it in two ways. So one is this particular way by finding out mean, median, and mode. And same proof we are able to get even by plotting a graph. So even by plotting a graph, we are able to find out the same proof. If data set is completely symmetric, means condition number 1, zero skewness. In that case, data set is going to form a complete bell curve, as you can see. If data set is rightly skewed, in that case, it will be able to form a tail on a right hand side, means there are very few data on a right hand side, extreme right hand side. If data set is left skewed, so in that case, you will be able to find out tail on your left hand side, on this side basically. So graph wise, so if you are going to plot the data x versus y, you will be able to find out a data set, a very less data set on your left hand side or on a negative side. So this is something called as negative skewness. And if data set is perfectly fine, in that case, you will be able to see a bell kind of a curve. This is something called as bell curve, right? Or a normal distribution curve, you will be able to find out in this particular space. Now, so as I have talked about, right? So as I have talked about a normal distribution with respect to this particular data. So what is basically a meaning of normal distribution, and how I will be able to find out that whether my data set is normally distributed or my data set is not normally distributed? Because whenever you will get a data, so you have to figure it out that whether my data set is normally distributed, whether my data set is not normally distributed, or my data set is falling under normal distribution or a standard normal distribution or Gaussian distribution. There are so many terms I'm going to talk about in this class, and one by one, so I'm going to explain you all of these terms, that when I'm saying like normal distribution, what is the meaning of it? When I'm saying Gaussian distribution, what is the meaning of it? When I'm saying a standard normal distribution, so now what is the meaning of it? And then I'll try to show you same example with the practical use case as well with respect to a code. So we'll try to code it and then we'll try to observe each and everything. Okay, fine. So here, let's talk about a normal distribution. So what is basically a normal distribution? So here, normal distribution. In other word, it's also called as Gaussian distribution. Gaussian distribution. So data set is called as normal distribution when it is going to form a perfect bell curve. Perfect bell curve it is going to form, means it should not be right skewed or it should not be left skewed. It simply means that its mean is equal to median is equal to mode. So then I will see that okay, fine. So there is a zero skewness into a data set. Otherwise, there is a positive or there is a negative skewness inside the data set. So mean should be equal to median equal to mode. So then in that case, we'll say that it's a normal distribution. Now, from the normal distribution, there is another term which has been derived, and that is something called as standard normal distribution. So from normal distribution itself, this particular term has been derived, and which is called as standard normal distribution. So when we can claim, so normal distribution means mean is equal to median is equal to mode, approximately, right? Now, when we can say that data set is under standard normal distribution. So when its mean is equal to 0 and its standard deviation is equals to, mean is equal to 0 and standard deviation is equals to 1. So whenever mean is equals to 0, mu is representing a mean and sigma is representing basically a standard deviation. So mean is equal to 0 and when it's sigma, standard deviation is equals to 1, then we can say that data set is falling under standard normal distribution. Simple. Now, for any given data set, right? For any given data set, so generally we try to use a function called as probability density function for any given data set. So whether data set is falling under normal distribution, standard normal distribution, or not falling under normal distribution or standard normal distribution, to find out this curve, because just by looking into this curve, you will be able to understand that whether data set is normally distributed, not normally distributed, or whether data set is skewed. Now that particular function, the probability density function, so there is something called as probability density function, and that function says that f of x is equals to 1 by standard deviation root 2 pi e to the power data minus its mean square divided by 2 standard deviation square. So this is basically a formula. This is a formula for a probability density function. Now, why we are talking about this formula? And this formula looks complex in a very first stage, but actually it's not complex, and don't worry, you are not going to do any kind of a manual calculation directly. So we have a function to do this particular calculation, and I'm going to show you that function as well in my today's class itself. Yeah. So you don't have to wait for the future class. So in today's class itself, I'm going to show you this particular function as well. Now here, right? Video is paused. Maybe today it's happened about 5 times. Is it, guys? I think streaming is fine, right? For every one of us. Yeah. Okay, so everyone is saying yes. So please try to check your internet connectivity, because my internet is fine and people are not facing an issue, as you can see in a chat. So those who are facing an issue, so maybe sometime what happens is like because of your net connectivity. So yeah, it may fluctuates, but sometimes streaming is stopping. Yeah, because of maybe internet connectivity, because from my side it's fine. Arvindan is saying pause often, because the streaming that we are doing is basically a 4K streaming, and because of this 4K streaming, so it takes a lot of data, So even on your side, so it consumes a lot of data, and maybe because of that you are facing this particular lag. You can try to reduce maybe quality as well. So maybe you can try to switch. There will be a gear button that you can see on a video stream itself. So from there, instead of auto, by default it will be auto. So maybe you can switch into a data saver mode. Yeah. So just try to switch into a data saver mode, and in that case, it should not give you issue basically, because it will consume a minimum amount of a data from your side. So when you are trying to access the stream, maybe many people have joined today. No, so it's a server, right? It's one server. So from one server, so it's broadcasting. So if I talk about a system design of this, so basically I am broadcasting to our like a main server, and from that main server, so it's a multiple broadcast. So that consumption depends upon your bandwidth, not on mine. Streaming from my side is fine, so that I can see over here. Just try to move to the lower resolution. So in that way, because I'm streaming a 4K from here, but yes, you can control that from your end. So what kind of a stream you would like to get from your end? Anyhow, your video will be available in a 4K. Okay. I'm moving to a lower resolution. Yeah, you can move to a resolution. That feature is already given to you, keeping the same thing in a mind. So even with the low internet connectivity, you will be able to join the classes. Okay, work fine now. Okay, yeah, like I said, so this is how like entire system works. So simple. Now coming back to this PDF, a probability density function. So this function says that whatever data is given to you. Let's suppose I have a data point X which is given to you, and obviously I will be able to find out a standard deviation for a data set, entire data set. I will be able to find out a mu, which is nothing but a mean for the entire data set. So I will be able to do this entire calculation. I will be able to do this entire calculation. So this calculation is going to allow me to draw this kind of a graph, the graph which I'm talking about. Because when I'm talking about a graph, let's suppose some data set is given to me and there are like a thousands of data set which is available to me. And if I have to plot a graph, so graph is nothing but a combination of a dots, right? Combination of a dots. Now, if I'll talk about one single dot, so in a 2D axis, if I'll talk about one single dot in a 2D axis, so it's nothing but it's a coordinate, right? It's x and y coordinate. So if I have a data set given to me, for example, if this is the data set which is given to me, so I have already a x, basically x coordinate with me, right? X coordinate with me. And for this whole data set, I will be able to find out standard deviation. I will be able to find out the standard deviation for the whole data set. I will be able to find out this mu, which is nothing but a average mean. And if I'm able to find out that, so for every x means for every individual data, I will be able to produce y, basically. So this is what it is trying to represent, and that y is going to give you a dot. Now, if you are going to plot all the dots, if you're going to plot all the dots, you will be able to see a shape of the data, that whether my data set is rightly skewed, left skewed, or my data set is a symmetric data set that I have. Simple, right? So this PDF, probability density function, is going to help you out to find out this particular y based on this data set X. You can go ahead and you can try to calculate it manually, right? Because this term is known. So I can try to find out a standard deviation for my given data set. For this data set, I can try to find out value of mu. I have each and every point inside the data, and then this is nothing but the exponent. This is nothing but a pi 3.14. And again, this is basically a standard deviation square, right? So for this whole equation, you have everything. You have actually everything. So even manually, you will be able to do a calculation and you will be able to find out a y coordinate. And if you are able to find out y coordinate of the data, then for sure, you will be able to plot the graph and you will be able to eventually see what is the tendency of the data set. Fine, guys? Yeah? Fine? Now, so live streaming के लिए कौन सा tool use हुआ है? So I'm using OBS. OBS is basically open source from my side. So when I'm streaming things, and yesterday when you have joined inside the class, so when we were doing a public live, so over there I was using StreamYard. So OBS and StreamYard. Okay. So just to answer your like non-technical question in this class, fine. So now let's do one thing. Let's try to open up your Python notebook. So I believe we have done some sort of a coding, NumPy and Pandas in our previous classes. And this was the reason, so that whenever I'm going to explain you something, so maybe I can try to explain it to you in a practical way. So open up any folder. So wherever you are going to create your document. So here, system is giving me, especially my document folder is giving me problem today. And the task. Okay, let me close it, guys. It is giving me some issue. Let me close my VS Code. Okay, so VS Code and then open folder. again stuck. I have not started my system since a very, very long time, and okay, so fine. So just try to create the folder, nothing else. And then inside that, so 12th Jan practical.ipynb. Fine. So just try to open up one Jupyter notebook, guys, so that we can see the practical and whatever we are discussing in terms of theory. So we can do it here itself. Now, to do this practical stuff, basically, so you have to open up or you have to import a couple of libraries. The very first library is, and I believe you all are aware about this library. So you have to import numpy, numpy, numpy as np. So this is the first library that you need as np. Now, the second library is, so you have to import matplotlib so that we can try to plot a graph. So matplotlib.pyplot as plt. So you can try to, because we are using a pyplot inside the matplotlib. Now you have to import from scipy, scipy is scipy dot stats. So import norm, and you have to import basically statistics package as stats. Okay, so these are the import that you have to do, and let me ping you inside a chat as well. So I have just pinged you guys. So these are the import that you have to do. Now just try to execute and check if something is missing inside my system. So select the Python environment, then Conda environment, and everything is working not fine for me. Let me check. It's executing. Yeah. So everything is working fine for me. So I'm able to import all the required library. So one by one, I'm going to use all of these library to show you a demonstration. The same thing that we are discussing over here. We are going to take a data set and we are going to basically plot a curve. And just by plotting a curve, so we'll get to know that whether my data set is like a normally distributed, whether my data set falls under standard normal distribution, this one, or my data set is right skewed, or my data set is left skewed, or my data set is a symmetric data set. This is what we are going to perform in today's class. Are you ready, guys? All of us? Yeah. Ready? All of us? Okay, fine. Now, so what you have to do is, so you have to first of all produce a data. So unless and until you are not going to produce a data, so obviously you will not be able to do a practical. Means you have to produce a X. So let's try to produce a huge amount of data. So not a data, this kind of a data. So where we have taken just like a 10, 12 data, and based on that we are trying to perform something. Because this is not going to give you much of result. Obviously in a theoretical calculation, that's completely fine. But yeah, in a practical, so obviously I'm going to produce a lot of data. So here I'm going to write maybe a data and numpy dot line space. So line space is a function that we have already discussed when I was talking about numpy package, and line space is a function so which is going to produce a data or generate a data for you between a given range. So whatever number of data that you would like to generate, you can generate it with the help of line space. So discussion is already done on this line space in my numpy class. So here I would like to produce a data between 0 to 10, let's suppose. And how many data I would like to generate? So I would like to generate maybe a 10,000 data. So 10,000 data I would like to generate which exists between 0 to 10. So it is going to generate a random data obviously between 0 to 10. This is what line space says. Return a evenly spaced number over the specified interval. So is overly like specified interval mein it is going to generate a data for you. So 0, and then like it is going to basically divide the entire scale between 0 to 10 into 10,000, and then So after a equal space, it is going to give you the data. Now you can try to use maybe a log space, you can try to use line space, you can try to use random function, rand n, rand int, rand only rand. So there are so many like functions which is already available inside NumPy, which you can try to use to produce the data set. Fine, I'll be using this. Now data, and this is a array, it will be able to generate and is holding 10,000 data set for me. One by one, you can try to extract a data and you can try to check. I think we all know that how to extract a data one by one. But yeah, so this is the data that it is going to generate for this particular code. Now what I have to do with this data? So maybe I can try to check that this data set is distributed in a normal way or not. Means this data set is normally distributed or this data set is not normally distributed as per the theory. So first of all, we'll try to check this one with the help of this, whether mean is equal to median is equals to mode or not. Or I'll try to check whether my data set is having a zero skewness, right skewness or left skewness, right? So this is the first part that we are going to verify. So here, just to verify it, I have to find out basically a mean, median and mode. So I can try to write numpy.mean. Inside numpy package, mean is already available. I can try to pass my data. Now mean of my data, the average of my data is basically 5. This is what I'm able to get. Now let's try to find out mode over here. So sorry, median over here. So numpy.median, median of the data. So median is equals to 5. So mean is equals to median. Okay, mean is equals to median. So mean is 5 and median is also 5 for me. Now here I can try to find out even a mode. So mode is available in your stats package. So this mode is available in your stats package. And again, you're not supposed to remember anything. Anytime you can go to Google, try to search. So where mode function is available and it will be able to suggest you a couple of libraries. One of these library is statistics. So here mode is available inside this particular library. This is the alias which I have created. So here stats dot mode, not model of the data, MODE, mode of the data only. So mode of the data. So mean is 5, median is 5 and mode is equals to 0. Means mean and median is greater than 0. This is what it says, right? Sorry, mean and median is greater than mode, or greater than 0 obviously it says, but yeah, mean and median is greater than mode. Now what is your conclusion, guys? So what kind of a data we are able to produce? A data with the 0 skewness, right skewness or left skewness? Anyone? Yeah. So what kind of a data we are able to produce? Data.mean, is it correct, sir? No, it's numpy. Numpy.mean and then provide a pass a data inside as an argument. So people are saying it's a right skewed data. Okay. Okay, fine. People are saying that it's a right skewed data, positive skewed data. Okay. Yeah, it looks like obviously it's a positive skewed data. Now I'll try to do one thing. So I'll try to find out standard deviation as well. So numpy dot standard deviation, I'm passing a data inside this function. Standard deviation is 2.88. Now tell me whether this data is falling under normal distribution or standard normal distribution. Data is falling under normal distribution or standard normal distribution. My standard deviation is 2.88 for this data, this given data. So can I say that that data set is not falling under standard normal distribution? Because if data set is falling under standard normal distribution, in that case, its average should be 0. So we have an average is equal to what? We have average is equal to 5, right? We have average is equal to 5 and this standard deviation should be equal to 1. So we have a standard deviation is equals to 2.88. So we don't have mean is equals to 0 and we don't have a standard deviation is equals to 1. So I can say that my data set is not falling under standard normal distribution, but my data set is falling under basically normal distribution for now. Okay, that's fine. So this is something that we are able to verify even with respect to our code. Now we have to plot a graph. We have to plot a graph where I will be using this function. The function I have written over here. So I'll be using that particular function in that particular graph. So obviously this is the probability density function. So I will be using that, and I will be using a function for it so that it will be able to calculate y f of x for each and every data set that I have. It will be able to calculate just by applying this particular formula. Okay, fine. Let's go and do it. So how I will be able to calculate a probability distribution or density function? So there is something called as norm I have imported from SciPy. So from SciPy.stats, so I have imported this norm. So this is going to give you basically PDF, right? So here I can try to call norm dot PDF. Okay, PDF. I can pass a data. So for every data point, for we have 10,000 data points, right? So for every data point based on this formula where it is trying to pass x and then rest, and it is calculating a final value of y basically. So x we already have from a data set. So we have a x coordinate, y coordinate we are trying to find out with respect to this particular one. So it is going to calculate. It is going to calculate this. It is going to give you the y. So I have applied a PDF, which is probability density function at x for a given RV, given data points. Fine. So this is what it says, even in terms of functions. So this is basically going to give you y at the end of the day, and the formula which I have written. So it is trying to calculate each and everything based out of the same formula. Okay, fine. So we are able to find out x coordinate, we are able to find out y coordinate. Now I have to plot all the dots. So 10,000 dots we have. For 10,000 dots we have x coordinate and we have a y coordinate. So we have to basically plot this entire things. So how I will be able to plot? So to plot it, again it's very easy. So to plot it, I will be using matplotlib pyplot. Pythonic plot I will be using from matplotlib as PLT. So PLT is nothing but it's an alias. So first of all, I'll try to create a figure, a canvas basically. So where my graph will be visible. So here to create a canvas, so PLT dot figure. This is what you are supposed to call. And then inside that fig size is equals to, means the canvas size, means the entire canvas size is, let's suppose I'm keeping like a 10 by 10 for now. Yeah. So 10 by 10 for now I'm going to keep. So this is going to create a figure, basically a box. It is going to create 10 by 10 of boxes. It is going to create in an expected ratio of my screen. Now inside this box, inside this figure, I'm going to plot this x coordinate, y coordinate, x coordinate and y coordinate. So here to plot it, I can try to call basically PLT same dot plot. So PLT dot plot, and inside that I can try to provide just my x data and y data. X coordinate and y coordinate. So what is my x coordinate, by the way? So x coordinate is going to be my data, right? This is my data. So this is going to be my x coordinate. So I'm going to pass basically my data over here. And then what is going to be my y coordinate? So this is my y coordinate, right? The PDF, the probability density function result is going to be my y coordinate. So maybe I can try to paste it directly over here. And now if I'm going to plot it, are you able to see x versus y, guys? Yeah. So on x-axis, I have a data ranging between 0 to 10. Even you can check the scale, right? Even you can try to check the scale. So I have basically a data ranging between 0 to 10. And this was the range of the data that we have produced, right? This is the range of the data that we have produced. And this is the range of the data that we have produced above. And this is nothing but it's coming from this y, because all this data, whatever data is available inside it, or this data, right? All this data, because this line is nothing but combination of a dots. Inside that even we will be having a data. So all this dot is nothing but a combination of x coordinate and a y coordinate, right? Then only it is able to draw something, then only it is able to plot something. So here is a graph that we are able to see. Type scatter line to unexpected keyword argument line 2D set. let me check its function. So type, let me just check how I can do a scatter plot. So here maybe I can just remove this one. So this is one of the graph. For the same thing, plt dot scatter, I can try to choose data, this. Yeah. So these are the dots basically, guys. These are the dots and it's combining all the dots. So basically there are like, it's too dense actually. So if I'm going to reduce a data, let's suppose if I'm just going to give 100, you will be able to see dots for this data. Now see, I've just selected 100. So every data is basically a dot representing x and y coordinate. X is nothing but your original data. Y is nothing but it's coming from PDF, probability density function. So which is been used to create a curve basically, or which has been used to create a bell curve, I would say. So this is something that I'm able to get for each and every kind of a data set. Okay, that's completely fine. So it is not forming, as we can see that it is not forming a standard normal distribution, and on this side, right? And on this side, which is a tail side of it, I have some data set. On a tail side of it, I have some data set, and it is trying to form some sort of a skewness. Although portion of the data or partial data set is trying to show me basically a normal distribution curve, but there are some data set on this side which is not trying to show me the similar kind of a tendency. Now what I will do is I'll try to create some more data set. So maybe I can go over here and I'll try to produce maybe a data 1, data 1, and this time I will be using numpy random dot rand n function. So I'll be using random dot rand n function. Now what this rand n function does, so rand n function, if you will try to see the definition of it, you will be able to find out that rand n function always try to produce a data which will be in a standard normal distribution. This is what a documentation docs says, right? That it will always try to produce a data based out of the standard normal distribution. Simple. So whatever data it is going to produce randomly, it will be on a standard normal distribution. So your mean is going to be 0 and your standard normal distribution is going to be 0. Okay, let's do it. So let me like produce 10,000 data out of this. So this, and maybe I can show you the data. So data 1, and it has produced a data. Now I don't know that whether this data set is a normal distributed data or maybe a standard normal distributed data. I'm not aware about it so far. So maybe I can try to find out a mean. I can try to find out the median. I can try to find out the mode. So fine, let's go and find out. So numpy dot mean and data 1. So mean is equals to minus 0.01, close to 0, right? Not absolute 0, but close to 0. Now numpy dot median. So here data 1, again I'm going to pass. So median is also close to 0, right? 0.01, so it's a fraction basically. And then I can try to find out basically a mode for me, right? So I can try to find out basically a mode for me. Now to find out the mode, so stats dot mode mode, and then I can try to give a data 1. So our mean, median and mode. So mean is, yes, looks like it's close to 0. So mean looks like close to 0. Median looks like close to 0, and even mode is not very far. So it's 0.30, which is again close to 0, I would say. So I can't say that like this data is in a absolute normal distribution, a standard normal distribution form. But yeah, it looks like that. It's close to a standard normal distribution where mu is equals to 0 and a standard deviation is equals to 1. Can I make this claim, guys, just by looking into its mean, median, and mode? Yes? Yeah. Okay. So its mean, median, mode is basically close to this one. So I can say that this data set which I have produced just now, it's following a standard normal distribution. So it is coming under standard normal distribution. Okay, fine. Now let's try to do a couple of more checks on top of this data. So data one, if I'm going to calculate directly a standard deviation, right? If I'm going to calculate directly a standard deviation, so numpy dot standard deviation and then data one, it's close to 1. It's 0.99, right? So yes, I'm able to verify that this data set is close to 1. Standard deviation is equals to close to 1. So mu is equal to 0 and standard deviation is equals to close to 1. So this data is a standard normal distributed data set. Now let's try to do a plot over here. So I'll come down and I'll try to plot it. So here maybe while plotting, so I can try to change this to data 1 and this to a data 1. Now let's try to plot a graph. Can I say that it is trying to form a bell curve, guys? This time, this data set is trying to form a bell curve, absolute bell curve. Yes, just by looking into this graph and even like just by doing some mathematical verification by using a mean, median, mode, standard deviation, we were able to prove the same thing. And even in terms of visualization of the data, we are able to prove the exact same thing. It's not very different, right? Now, if I'll have to show you a scatter plot, means a dotted plot. So even over there, so you will be able to see that this is forming. So it's like too dense, right? And this dots are forming a standard normal distribution, right? So for every dot, there was a X and then Y is been produced with the help of PDF function. And there are like very few dot out of this 10,000 data, which is behaving like an outlier, but not much. Yeah. Not much of the data is behaving like a outlier out of this entire data set. So yeah, we are able to prove our theory. So theory says that mean, median, mode should be equal. In that case, data should not be skewed. We are able to prove that. And standard normal distribution. So yes, data set is forming a standard normal distribution if mu is equals to 0. Now here, if you will see, its middle point is at what? It's at 0, right? Its middle point is at 0. This one is at 0. So yes, its average is equal to 0. And even by doing a mathematical calculation, we were able to prove the exact same thing, that it was actually a 0. So hope this works fine for you. So any question, guys, for me, please ask me in a chat. So if you have any kind of a question, I'll try to answer. Okay, so Andra is saying, no, sir, can you tell me the importance of standard normal distribution? So if data set is falling under standard normal distribution, then you don't have to do any kind of a treatment as such, basically. So your data set, even it is not just a standard normal distribution, even it is falling under a normal distribution. So you don't have to do any kind of a treatment. So your data is eligible enough for most of the algorithms. Again, for most of the algorithms, so where you can send your data and you can try to start doing a training, machine learning, like a model building. Difference between normal distribution and standard normal distribution. The difference between normal distribution and standard normal distribution is, for standard normal distribution, your mean is going to be 0, your standard deviation is going to be 1, and for a normal distribution, it could be anything. Okay, fine guys. Any other question for me? Okay. So mean is equal to 0, standard deviation is equal to 1 is the thumb rule for SND. Yes, that's a thumb rule for SND actually. So I believe Euron system has given you the same answer, right? Use case of a standard normal distribution. It's been used to check the quality of the data basically all the time. SND and normal distribution both. So to check the quality of the data and to check whether there is some outlier or not, whether there is a ambiguity inside a data set or not. For example, I have already given you this one, right? I have already given you this particular example. So where we had a ambiguity in this data set, we had an ambiguity, like we had 100 and we had 200, which is way beyond the actual range of majority of my data set. So in that case, so before sending this data for any kind of a training or something or learning, I have to remove or I have to normalize this data set, right? So that is the actual use cases which you are going to use not in just one algorithm, but in almost 99.99% of the algorithm. You are going to use it. Fine. Okay. Now, so move to the next chapter, next part of the same thing, right? So now we are able to understand what is the meaning of a normal distribution, what is the meaning of a standard normal distribution when we can say data set is left is skewed, right is skewed, or data set is a symmetric data set. I believe we all are able to understand this entire thing. Yeah. Euron chat is awesome, sir. Yeah, so it is giving you back to back all your answer before even I can give the answer. And that's the reason so we have deployed this solution because uh, generally what happens in a live class is there will be like a people, so many students, and then they will keep on asking their doubts. Some of them are going to ask repetitive doubts, and mentor, obviously mentor has to teach in a live classes. So this is basically a helper for us. So this is like basically behaving like a helping hand for me or any other mentor that used to join Euron. So okay, now so based on this normal distribution, so hope all of you are able to understand and you're not feeling like this mathematics part is too heavy. Yep. Actually, it's very logical. Like everything is very logical. Thank you, Rajendra. Okay, so let's suppose I have a normal distributed curve. Normal distributed. So when I'm saying normally distributed, so it means that your average, which is mean, and your standard deviation not supposed to be one and 0 and 1, right? Mean is not supposed to be 0, and standard deviation is not supposed to be 1. This is what I mean by normal distribution. But yeah, curve is going to be perfectly bell curve. That is the meaning of normal distribution. Now, so if you are going to divide this entire curve, this line is not straight. So if you are going to divide this entire curve from middle, so 50% of the data will fall on this side, and obviously 50% of the data fall on this particular side, right? 50% data is going to fall on this side and 50% of the data is going to fall on this side. Now, further we can try to divide this entire graph, right? And we can say that if data set is showcasing a normal distribution, right? If data set is showcasing a normal distribution in nature, so inside this graph itself, you will be able to find out again three portion on this side and on this side, right? Now, so yesterday we were talking about standard deviation. Now, as per our discussion, so standard deviation is nothing but it's basically a distance from a mean, or how much like data is dispersing from the mean. This is what is like a meaning of the standard distribution, right? So this is what we try to find out by finding out the SD. Now here it says that approximately, right? Approximately 68% of the data, approximately 68% of the data will fall under this particular reason. So let's suppose I have maybe 1000 data points or maybe just 100 data points. So out of 100 data points, if those 100 data points, only if those 100 data points are forming a normal distribution curve, and it may form a standard normal distribution curve as well. So in that situation, 68% of the data, 68% of the data will exist approximately again. So 68% of the data will exist in this particular region. So this is half of the region, this is half the region. So you can just do 68 by 2 and you will be able to find out how much this side, how much this side, right? So 68% of the data will be holded by this region itself, and which is called as one standard distribution. So within one standard distribution, so when I say, right, when I say that standard distribution is equals to 2.8, for example, I believe we found out this, no, we haven't found out the standard distribution for this data. We have found out the standard distribution of this data, right, over here. Standard distribution of this data we are able to find out, the linear, like a linear data that we have produced. So we are saying that standard distribution is equals to 2.91. Now what is the meaning of this? I have produced 10,000 data for this data point. So I have produced 10,000 data. Now the meaning of this standard distribution 2.91 is that 68% of the data, and half of it is going to be approximately 34%. Approx 34%. It's basically 33 point something, but yeah, let's take a lump sum value. So approximately 34% of the data and 34% of the data, 34% of the data this side and this side combinedly, this region is going to hold 68% of the data, 34 this side and 34 approximately again, guys. So I'm not going after the fraction part. So approximately 34% of the data will be holded this side, 34% of the data holded this side. Meaning is that if my standard deviation is 2.91, so under one standard deviation means 2.91 from what point? So from my mean. Now what was a mean for this data? 5, right? So mean for this data was actually 5. Let's imagine like my data was normally distributed. I'm assuming that. So based on that assumption, so 5 plus this and 5 minus this is going to hold 68% of the data. So mu plus minus, I would say, one standard deviation is going to hold 68% of the data. You can even try to check manually. You can try to check even with respect to a small data set, this particular data set, and I believe I have already done the calculation yesterday. So if you are going to do a calculation of a standard deviation for this data set, and if you are going to find out like a mean plus standard deviation, one standard deviation, and mean minus one standard deviation, almost 60% of the 68% of the data set you will be able to find out falling under first standard deviation. This is the meaning of standard deviation, guys. Generally people think that whenever we are able to find out standard deviation, so 100% of the data, because standard deviation says that it's a distance from a mean, right? It's kind of a distance from a mean, dispersion from the mean. So people generally think that all the data set will be available inside that distance from a mean itself. But no, that is not true actually. Then the second point is almost, right? Almost, I would say. So almost 95% of the data, 95% of the data will fall under two standard deviation. This side combinedly and this side combinedly, right? 95% of the data. So if you are going to take this entire region, so this region will be holding 95% of the data, which comes under two standard deviation. So mu plus minus 2 standard deviation is going to hold 95% of the data, still not 100% of the data set at any point of a time. And again, so when we will be calculating a Z statistics, T statistics, P value calculation, or student T distribution. So even at that point of a time, this concepts will be very much useful, right? Just to find out the skewness into a data set or outlier into a data set. So this is what it says. Then it says that approximately 90 blue line, guys, blue line, right? Focus on blue line this time. So it says that approximately 99.7% of the data will be available inside 3 standard distribution. So, okay. I'm just trying to draw a perfect figure, guys, over here so that it looks fine and we can post it over social media, LinkedIn at least. So I'm just trying to achieve that perfect figure. So 3 standard deviation, 3 standard deviation, right? So that anyone can use it to post it anywhere. So yeah, 99.7% of the data, it says that it will be available under 3 standard deviation. So approximately like all the data will be available under 3 standard deviation, and you can even cross check. You don't need a big data set. You can even like check with this data set that out of like this entire data set, which is like 2 to 4 to 6 to 8 to 10 to 12. So out of this 12 data set, how many data set is falling under this 68 percentile, then 95 percentile, and this 100 percentile or 99.7 percentile. So this is something that you will be able to know. So area under PDF is equals to 1. Yes, that's true. It's considered as 1 because, okay, so why I'm talking about this one? And again, it's 100% that I'm talking about, right? It's 100% that I'm talking about. So now what is the meaning of 100%? Because this is basically a probability density function, right? And just tell me one thing, guys. So probability ranges between what to what? It's actually a PDF function, right? Probability density function I'm talking about. So probability always ranges between what to what? 0 to 1, right? Probability always ranges between 0 to 1, or percentile wise if I'll say. So obviously 0 to 100, right? So nothing in terms of probability. So none of the probability in this entire world can go beyond 1 or 100 percentile and below 0, right? So it will be always between 0 to 1. So basically the graph which I'm trying to plot with the help of this PDF function, the complex like a formula that I have written over here. So it is trying to tell you that whatever data, the occurrence of a data in a particular area, it is trying to tell you. So let's suppose in future, I'm going to give you a data. Now, I'm going to ask you a question that what is a probability that most of the data, right, will be like or what is the probability that this particular data out of this data set will fall under which percentile, basically, right? So that you will be able to do a better treatment of the data going forward. So this is basically a probability which I am trying to teach you with the help of graph. And this graph again shows the exact same thing that we are talking about. Yes? Fine, guys? So people are asking that how we can say that 68 point or 95 percentile. So basically, whenever you are, so basically I'm calling from this one. So whenever you are going to take any random data with any kind of experimentation, so based out of this formula, I'm going to say that 68% of my data is going to lie under. And if I'll try to find out the probability of occurrence of a data one by one, so I will be able to get the same result. Yep. So fine, guys, hope all of you are able to understand this part. And yeah, so this looks great. And I believe today we are able to even understand that what is basically standard deviation means. So what is the meaning of one standard deviation? What is the meaning of two standard deviation? And what is the meaning of three standard deviation? And what percentage of the data will be accommodated by 1, 2, and 3 standard deviation respectively? So let me write it down over here. I have not written this. So mu plus minus 3 standard deviation is equals to 99.7 percentile, approximately like 100%. Okay, fine. So any question for me, guys? So if you have any question for me, please go ahead and ask. Okay, so if there is no question for me, so maybe we can try to like move ahead. So in my next class, I don't want to start this today because I don't think that we'll be able to get enough time. In my next class, I'm going to teach you that let's suppose my data set is available in a normal distribution, right? Means my data set is forming a bell curve. But you will be able to find out eventually that sometime with some of the machine learning use cases and even statistically, uh, in some of the use cases, you have to convert your normally distributed data set into a standard normally distributed data set. Means, so a data set which is not having mu is equal to 0 and sigma is equal to 1 to a data set where mu is equal to 0 and sigma is equal to 1. So you have to convert normal distribution to a SND, like standard normal distribution data set. So how that is particularly possible and how we'll be able to do that. And this is where I'm going to introduce something called as Z score. And in my next class, so we are going to look into even a Z table, T table. So there are like, I think you all are aware about like a log table, right? So even in our childhood, if you are 90s kid, because nowadays I believe calculator is allowed in a classroom and even in an exam hall, but in our time, so calculator was not allowed. And like a teacher used to give us like a entire log table. So based on that, we try to do a log calculation. And again, for a statistician, so it's basically a Z table, T table that they used to take. So there is something called a Z table, there is something called as a T table, which exists over the internet. So based on that particular table, so we'll try to understand and we'll try to see and we'll derive it basically that how if a data set is not available into a standard distribution, so how from normal distribution, I will be able to convert a data into a standard normal distribution. So this is something that we are going to discuss in a very first class and where I'm going to introduce this formula. I'm going to explain you what is this Z statistics. There is something called as Z statistics. So I'll try to explain you that part. Plus I'll try to like show you how to look into a Z table. It's very, very easy. Believe me, it's nothing actually. It's a very simple step, but yeah. So I'll try to explain you with a practical example. So that will take some time, maybe half an hour of time for me to explain you. And apart from that, so I'll be talking about even a T table. I'll be talking about even a P value. And if time allows, then I'll try to go into a further topic like a chi-square test, ANOVA test, and many more things. So I believe in next week, 2 classes, we will be able to cover lots of statistics and lots of mathematics. And then eventually we'll try to start our step-by-step machine learning algorithm. Making sense, guys? Yeah, inferential statistics. Yep. Okay, so with that, guys, I believe I'm done for today. So if you don't have any kind of a question, in that case, what I will do is I'll try to upload this PDF inside your so stats underscore data underscore science underscore English batch. So I'm uploading this PDF. And apart from that, so I'm uploading this piece of code as well, so that now itself, so that you will be able to access it anytime you want. So okay, so let me upload, choose a file. Okay, so one is done and the second PDF is also done. In a later stage, it will be available inside your resource section so that you can access it anytime you want as per your convenience. Okay. So after stats, so in between stats itself, so I'll be covering linear algebra. So basically in linear algebra, so I have to cover equation of the line y is equal to mx plus c. And the amazing part is your very first algorithm, which is basically a linear regression, right? It's completely based out of that equation of the line y is equal to mx plus c. So I'll be talking about that in a very, very detailed way. So maybe you have not even gone through in that kind of a detail when you were in like your 11th or 12th. So when you were like learning those equation of the line. So I'll go in that kind of a depth of that. And yeah, so linear algebra, anyhow, we are going to cover probability distribution. Anyhow, I'm going to cover. So we'll progress as per the need. Machine learning will be bought after the inferential. See, machine learning, when I say machine learning, right? So most of the machine learning algorithms, you will be able to find out that it's a pure mathematical derivation. So math, machine learning will go hand to hand. In this way, I like generally used to progress my classes so that you will not feel bored. Because if I'll just start teaching you just statistics back to back, right? Believe me, all of you will feel bored. You will say that this class is even like much boring than the class which I have attended in my 11th and 12th. And I don't want to make my class boring at all. So keeping that in a mind, so and believe me, at the end of the day, the goal is you should be able to understand. Plus, whenever you will go to an interview, you should be able to explain the same thing to your interviewers. That's the whole objective, right? So learning is not just our objective, because for our learning purposes, we have so many materials, books and everything. And as you can see in my back, so I have a lot of books, even like on other side of the wall. So I have thousands of books. So learning is a never ending process, but yeah, so we should do a useful learning. Fine guys, hope all of you are liking the class. Yes, so if you're liking the class, so please try to go post, comment, try to build your network as much as you can. And from our side, from a Euron side, so we'll keep on bringing amazing batches for all of you. And the intention behind creating Euron Plus is very simple, that anyone and everyone is just supposed to pay one single. So how is this like, I just wanted to like know the review guys. So what is your feeling about Euron Plus? One student, one subscription. Because my intention is to create a OTT of an education. Because education is very much scattered. There are so many people in a market who is launching a batches. Obviously, like some of them are even way better than me. I'm not saying that they are not better than me. They are better than me. They are much more knowledgeable than me, much more experienced than me. So everything is fine. But again, so from a student side, so you have to go, you have to pay again and again and again and again for like every batches. And learning is something which is a never ending process. And the way technology is changing, again, it's going to be like a frequent learning that we all have to do. So keeping that in mind, so I thought about this module called as Euron Plus, where just single subscription, if we can watch a movies over the internet with a subscription, so why can't be a study with a subscription? Yeah, so we have like a OTT, lot of OTTs for watching a movies, or maybe a song, or maybe like a audio books, even for a books. We have such kind of platform, but for education, where you can learn all the tech, maybe a web development, maybe a DevOps, maybe a cloud, maybe a MLOps, maybe a big data, maybe a data science. Plus, in a couple of weeks, you will be able to find out that we are taking an initiative in some regional language as well. So Indian regional language. So we are taking initiative in a Kannada language. So we have a mentor for that. We are taking an initiative in a Bengali language. So again, so we'll keep on expanding it as we will like keep on finding a kind of a mentor that we are looking for in a all regional language as well. So that people can learn, because many people are not able to understand things because of like a language barrier somewhere. So we have to remove that part as well. Economically it's great, sir, with the price range and the content quality. Sir, please to be in an Indian version course. Yeah, it will take time. I'm not saying that by next month I will be able to build the actual OTT, but yeah, I have a vision, and it is going to take maybe a year and a half of time. But this is the initiative that I have taken, and let's see. Obviously, if we are working day and night on that. And yes, if we are able to get your support, a lot of support we need. So if you can just go outside, spread the word. Even you can try to build your own network. It's completely fine, right? It is going to help you out as well. It's not just going to help us. It is kind of a mutual. So it is going to help you out, and yeah, so we all will be able to enjoy its benefit. So with that, guys, thank you so much, and see you again on my next Saturday class. Same place, like from a dashboard, you can try to join. And I believe I have already set the agenda of the next class. So what we are going to discuss in my next classes. So let's come to the class and try to have a discussion as much as possible. And most probably I'll start giving you like a lot of assignments as well, but not now, after a couple of classes. So after 2 or 3 classes, I'll start giving you assignments. See you, sir, in big data. Yeah, in next 15 minutes, I have another class, which is a big data. So by that, thank you so much. Thanks everyone. Take care. Good day.